So in this tab, we're looking for the strongest performer. So we're actually going to be doing a comparison, which is really important because the number one act in statistics is always comparison. So we have Delaney, who sells in the rural division. So the rural division, Delaney, where sales are distributed 30,000, 5,000. So first let's try to figure out the case. So it's here it says, who's the best performing employee by percentile? Percentile means looking left. All right, so for Delaney, it's normally distributed mean of 30,000, standard deviation of 5,000, and she beats her division by 7,000, so she's at 37,000. Okay, so Delaney's out here at 37,000. And we need her z-score. So that's going to be equal to x minus the mean. Remember, it's difference from the mean, but measured in units of standard deviation. That's why we divide by standard deviation. So she's 1.4 standard deviations above the mean at 37,000. And to get the probability, since we're looking left, we use this one. It's going to be norm.s.dist z true. Okay, so there's the first one. Now we have Delaney. Now let's look at Nick. So Nick works in the urban division. So urban, Nick. This is again percentile, so again looking left. And his mean is 35,000 for that division. And standard deviation is different. It's 10,000 in that division. And his sales are 40,000. Okay, so Nick is right here. And notice these are on different scales, right? Delaney's the red scale. Nick is on the black scale here. And the scales really are different. The means are different, but they also go up differently. This goes up by 5,000 for that standard deviation, or this one goes up by 10. Okay, so the z-score for Nick is x minus oops, picked the wrong number. X minus the mean divided by the standard deviation. And then his probability is going to be equal to norm.s.dist z true. All right. So you can see here, they're both looking left. There's Delaney starts, and then Nick's distribution is black. And so you can see they overlap, and you get the red and black interlacing here. Okay, so who's the top performer by total sales? In other words, actual sales dollar amount. So we can actually get all this from the graph. So Nick's at 40,000, Delaney's at 37,000. So in terms of dollars, it's Nick. Don't worry about that not lighting up yet. We've got to get all three right before this will light up. The top performer by division percentile. By division percentile. So relative to their own division. So basically it's your percentile. Well, Delaney's 91%. In other words, she's doing great in her division. Nick is not doing as well relative to his division. So this is Delaney. And top performer by sales above division average. Okay, again, it's Delaney, right? She is well above her division average. Okay. What sales does Nick need? Okay, now we can play around a little bit more, feel for the numbers. What sales does Nick need to achieve the 84th percentile? So there's the 84th percentile. Nick is on this scale here, the black scale. So he would need 45,000. What sales does Delaney need to achieve the 97.5 percentile? 97.5, Delaney's on the red scale, 40,000. When I say red, I mean the rural scale. And what is the percentile difference between Delaney and Nick? And for these, we need to reference cells. So there's Delaney minus Nick. And now we get two questions that these are probably the hardest ones on the page. At what sales volume does Nick match Delaney's percentile? Okay, so we're trying to get Delaney's percentile. Now remember, there's a direct relationship between percentile and z-score. So we're going to start with Delaney's z-score. And we're going to use her z-score, pretend that Nick has it, and see if he had that z-score, what would his x value be? So we're going to say equals Delaney's z-score times Nick's standard deviation, which is this one, plus Nick's mean. And we're actually using this formula here. X equals z times standard deviation plus mu. So that's 49,000. At what sales volume does Delaney match Nick? So now we go the other way. So we're going to, we need Nick's percentile, but remember, Nick's percentile is directly related to Nick's z-score. So we're going to use Nick's z-score. So it's Nick's z-score times Delaney's standard deviation plus Delaney's mu, and that's 32,500. And we're good. So a lot going on here. What I want to point out is you've got lots of simultaneous axes. You've got the standard normal distribution, that's the 0, 1, 2, 3. You've got the percentile axis. You've got the z-score axis the standard deviation axis for the rural population, the raw data axis for the rural population, and the standard deviation axis for the urban population, and the raw data for the urban population. And if we put a little x here for empirical rule, then we'd even throw in those percentages too. So we would end up with 1, 2, 3, 4, 5, 6, 7 x-axes. Seems like a lot, but if you can use these x's to remove things to kind of make it easy to follow, just what you want to follow in order to draw your attention.